Hey guys, welcome to this webinar, getting started with Linux. And today we're going to be talking about how to get started with Linux. I'm going to give you a primer on how to get started, just some basic information about the Linux operating system. And that's kind of what we're going to be doing today, and just how you can get your hands on Linux and just some basic information about it so you can get started using the operating system today. I'm Blaze Stewart. I'm an architect at Wintellect, and Linux is one of my passions. I really love the operating system. I'm not a diehard though, because I'm bringing this webinar to you from a Windows PC. So, and some of you may be listening on a Mac, and so we have a lot of different aspects that we can talk about. I'm not here to tell you to get rid of your Windows PCs. I'm going to get rid of your Mac, Apple products or anything like that today. It's mostly just to let you know about this operating system and get you started with it so you can start using it. So let's talk a little bit about who we are at Wintellect, just for briefly, and then we'll dive right into the content. Wintellect is a consulting company and a instruction company. So we do both consulting services, and we also have instructor-led training, which is where you bring us on site, and we instruct you on technologies. And we also have a on-demand training with our Wintellect Now. And all these various lines of business give us a lot of influence in the industry. We've actually had several of our co-founders, as well as many of the consultants at Wintellect, have written some of the more popular works in the .NET space related to, like Core CLR by Jeffrey Richter, or Jeff Procyse's book on Microsoft MVC. These are both kind of classic texts for .NET developers or Windows developers and things like that. And we also have a lot of tight relationships with Microsoft, including we're Azure Gold Partner. We were the IAMCP Partner of the Year for 2016 and 2018. We were worldwide and the U.S. Partner for the year. We have multiple Microsoft MVPs. Our CEO is our regional director for Atlanta for Microsoft. We have multiple DevOps Rangers. We have a lot of different relationships with Microsoft and lots of different programs. So needless to say, we are very tightly tightly integrated with the Microsoft ecosystem. And because of Microsoft's more openness to open source in the last few years, Wintellect has certainly gained an interest in how we can relate to open source and how we can relate to the Linux operating system, specifically when talking to people who have traditionally been on the Microsoft platform. So that's where I kind of come in, and that's really where I like to focus a lot of my effort and attention on. So let's dive in and then look at a comic just real quick. So the OS, the operating system then and now. So if you used Windows way back in the day, you remember Windows 1.0, it looked something like that first little thumbnail there. And then now, well, that's actually a screenshot from like Windows 7, but the GUI has changed a lot. And same thing with Mac OS. It started off with monochrome, and then you got down to this more fluid design that they have with the dock and the drop shadows and that classic design that we all expect from Macintoshes. And Linux down there, it looks the same like it did 30 years ago. It's a CLI. At least that's the concept, the popular perception of Linux, because Linux is in the heart of many people, it's a CLI only operating system where you have to know everything about the command line interface, and you have to be like this super duper skilled hacker to even begin to understand and appreciate the operating system. Well, I hope today that I can kind of dispel this myth about Linux, where you have to have deep, intricate knowledge of the operating system to even begin to use it. It's really not as hard as most people might think. And so I'm going to kind of help ease you into Linux and maybe get you interested in it and show you a path forward that can get you into the operating system without having to know even the beginnings of the command line. But at the end of the day, if you really want to take advantage of Linux, having the command line at your tool belt is knowing how to use the Linux command line, and knowing all the tools that are available in the command line is really going to make the Linux experience all the more rich. So let's dive right in and look at this operating system. First question is what is Linux? Linux, strictly speaking, is the kernel of the operating system. Now, if you ask a purist, a Linux purist, they're going to say Linux is really nothing more than the kernel of the operating system. When you talk to some people that are just developers and they're like hardcore into this idea of Linux, they're going to say everything else that's outside of the Linux space is really just fluff. That's really not what we mean when we say the word Linux. But broadly speaking, and more the kind of popular conception of Linux is any member of a family of operating systems that are based in the Linux kernel. So this could be the Linux kernel plus all the software that goes into building out a full-blown operating system, or what we've come to appreciate as an operating system. So I'm going to use Linux in the broad sense of the term to refer to not just the kernel, but everything that comes packaged with it whenever you go to deploy this into whatever mode that you want to deploy it into. So when I say Linux, I'm really talking about Linux kernel, the tooling, the CLIs, GUIs if you're using them, and everything that kind of comes along with it. So a little bit of a history behind it. Linux was developed to create a free distributable Unix-like operating system, and that was kind of the original intent behind Linux. And it was developed by a guy named Linus Torvalds, and he was a Finn, and he developed this in response to a project that is called Minix, which is an operating system designed for instructional use. And Linus wanted to use Minix to produce an operating system that was generally available and free. And the guy that developed Minix didn't want to give it away in that sense. He just wanted to keep it for educational purposes only. So Linus went and wrote his own operating system and kind of borrowed from Minix until he had a complete operating system that became Linux, essentially Linux 1.0. And it has since then been developed by thousands of developers all around the world, contributing code to it. And Linus Torvalds is also the guy that gave us Git. So if you're using Git in any context, be it with Microsoft, DevOps, or you're using it on premise, Linus Torvalds is also the man that kind of gifted the world with Git and Linux. So he is kind of a legend in the open source space, and will definitely go down in history as one of the greats in computer science. In short, Linux runs on everything too. So it's kind of hard to speak about Linux in generalities because it does cover a big swath of compute. So it runs on everything from embedded systems such as controllers in like a weather collecting environment, like a weather station. It runs on mainframe computers. It runs on mobile devices. Like Android is a flavor of Linux, and it's based on the Linux kernel. It runs on personal computers, like so you can run it on your laptop or a desktop. It runs on servers, which is one of the most popular uses for it, and probably the one that most people interact with on a day whenever they're actually doing Linux in a development context or in a sysadmin context. And then it also runs on supercomputers. It runs on actually top 500 supercomputers in the world all run some version of Linux, some custom version of Linux. But needless to say, it runs on a lot of different platforms, and that's because it's open source, so it can be kind of adapted to whatever need it needs to be adapted for. And collectively, Linux is the world's most populating operating system as of today because it's just running on so many different devices. All the various flavors of Linux collectively make it the world's most popular operating system, hands down. More than anything that's even a close second would be maybe Windows, but Linux has the lion's share in that case. Just a few statistics related to that. 70% of the world's smartphones run Linux. I think that number might even be higher now. That's because of Android. 54% of tablets use Linux. 99% of smart TVs use some version of Linux. 99% of set-top TV boxes use some version of Linux. 36% of websites run on top of Linux. For context, Windows runs about 30%. The other percentages are made up by operating systems like BSD and other ones. And then 100% of the world's top 500 supercomputers run Linux, but only 2% of desktop computers use Linux. And that's kind of, you might be shocked to hear that, considering it's used so widely elsewhere, why only 2% of the world's desktops use Linux. That's because Linux really has not had a has not really delivered much in terms of providing a general purpose operating system that really caters to the masses. And while Microsoft has, and they've captured the lion's share there with Windows on the desktop as well as Mac OS, has double-digit percentages of the desktop market as well, and Linux just has a paltry 2%, and actually most of that is made up by Chromebooks. So it's a small percentage of the Linux market. And even so, though, the Linux desktop market is still one of the most highly competitive parts of the Linux ecosystem, and we're going to talk about that. And in fact, I'm going to focus in on this small percent here today, because this is how you can get into Linux without actually having to install it and just go straight to the CLI for that matter. So with that in mind, let's go to the next slide. I'm going to introduce you to some lingo, and then we're going to do some demos. So you have to bear with me a little bit here. A Linux distro is kind of is a distribution of Linux. So we've talked about the various kinds of use cases of Linux. So we've talked about how it's being deployed, say on all these different embedded systems, supercomputers, desktops, and servers, and so on. But now we're trying to talk about different distros, and these are kind of the versions of Linux, if you will, the various flavors of Linux that you can deploy on all of these different kinds of devices. So a distro is essentially a flavor of Linux that has that is an operating system that is built on top of the Linux kernel. So a distro tends to do a lot of the things that a typical operating system handles. So the Linux kernel being the core of the operating system, the distro then takes that Linux kernel and builds around it an ecosystem. And that distro then is responsible for things like handling the bootstrap and system management and things like that. It also comes with something called a package manager. So the package manager is responsible for getting software from its source onto your system. And so every distro is going to implement bootstrapping the boot process of your device differently. It's going to handle how services start up on that device differently. It's going to manage processes, how you start services, shut them down, where you configure those services. It's going to handle, every distro tends to handle each one of these little aspects of the operating system slightly different from the other ones. And depending on your context, that can be a point of frustration, but it can also be a point of customization as well. So if you need to really tailor something to your liking, not having that ability to really tweak everything to the nth degree really makes it a very customizable experience, which is one reason that people use Linux in the ways that they do. But even so, the package manager is the thing that kind of takes the edge off of using a lot of Linux systems, because the package manager is the piece of the operating system that, as I mentioned, gets things from the sources onto your system. It is the thing that is also going to track dependency. So if you need to install, say, a web server, and you just run one command or install that web server, so what the package manager is going to do is it's going to install a bunch of other supporting software that your web server might need to make your website run on top of that web server. So the package manager does help take some of that edge off of, so you don't actually have to go out and find the source code and then find the libraries, compile the source code, and then install all the compiled code into a particular folder and set it all up manually. The package manager is going to expedite a lot of that process for you. While in the past, if you were using Linux, like in the early days of Linux, you pretty much had to build everything from scratch yourself, compile it, install it, maintain it. Package managers will even do things like update things for you automatically if you want to, and among a lot of different things like that. So distros, to summarize, are the Linux kernel plus the ecosystem around that Linux kernel plus the package manager, and those kind of things sum up what a distro really is. So with that in mind, How many different distros are there? Well, literally hundreds of them. The Linux family tree looks something like this little graphic here. And I actually want to zoom in on this graphic a little bit. I'm going to swap over to a browser and show you what this looks like. And so this graphic looks something like this. And I do want to touch on some of these distros. And there's families of distros that we can talk about, and there's several of them that are more popular than others. And this first one up here, this first tree that you see here, is Debian, and Debian is a very popular distro that is the mother of several other popular distros. So Debian is one that I use a lot in various contexts, and its progeny, particularly Ubuntu and Knoppix. Knoppix is a boot from DVD or boot from CD distro or boot from thumb drive that is a self-contained operating system that you can pop into your USB drive and run the entire operating system right off a thumb drive or right off of burned media like a DVD. And Ubuntu, if you've heard anything about Linux, usually most people have heard about Ubuntu because it's very popular, especially among enterprises and other sorts of applications that people are using on their desktop or even in the cloud. It's many different companies will release software on the Ubuntu platform because it does have wide use in the Linux community. And you can kind of gather that just by the sheer number of distros that have been forked from Ubuntu. And Ubuntu is really not even that old in the context of the entire Linux story. It really is only about 15 years old, while Linux itself is about 25 years old, or almost 30 years old now. So it hasn't been around as long as other distros have, but it is the basis for a lot of various projects. And because of that, it's one that many people will gravitate to. And in fact, it's going to be the one I'm going to be using for my demos today. And then the Debian itself is very similar to Ubuntu in many respects, but it also differs too. And you can see how it has been the mother of many different distros as well. Slackware is another more purist variety of Linux. It's the mother of SUSE Linux, which is very popular for people that like secure or very fine-tuned Linux. Slackware is a really nice one for that. I'm not going to spend a lot of time talking about it. The other one that is probably one of the more popular ones is Red Hat-based Linux, and its progeny, which would be Fedora, which is Red Hat Enterprise Fedora, and Fedora originally started off Fedora Core. And Enterprise Linux is the basis for CentOS, which is one of the most popular distros out there. Oracle Linux and then Red Hat Enterprise Linux all kind of fall into the Red Hat camp. And it's got a lot of various derivative work from it as well. So you can see that from all of these other various distros out here. And there's a few other ones that are out there that I do want to mention. Gentoo is the basis for Chrome OS and Chromium OS, which is what ends up on Chromebooks. Arch Linux is a very purist approach to Linux, and a lot of folks like Arch Linux simply because it does give you a very minimalist, very pure approach to just getting something up and running. A lot of like hardcore Linux users like Arch Linux for that reason. And then, of course, these are some more of the more esoteric ones that haven't spawned the ecosystems. And then lastly, Android down here. And to call it, there's a debate in the Linux community as to whether Android really is a distro. Most people consider it a distro because it does work like a distro, but it isn't as open as others are. But it does have its own kind of ecosystem growing, as you might be well aware of. Android has, Android's own package manager through Google Play, and it has actually birthed a number of open source projects like CyanogenMod and Lineage OS, and then there's Android x86. Which is available as well. So let's go back to the deck and just kind of give you a summary table of what this might look like and what you can expect from this. So the Linux ecosystem, it's really, like I said, you have the family, Debian. It uses a package manager, as we mentioned, a package manager a minute ago. It's called apt, and you've probably heard of apt-get if you've ever seen anything in Linux. And as we mentioned, Debian, Ubuntu, and Knoppix are the popular derivatives of that. Then there's the Red Hat family. It uses a package manager called Yum, which actually didn't originate with Red Hat, but they picked it up and kind of adopted it. And the package format is RPM. And again, as mentioned, Red Hat Enterprise Linux, CentOS are some of the popular derivatives of it. And then of these other ones down here are some of the more, these three here I did want to put on here just because they are popular enough to mention, because they do have a following in the Linux community more than some of the more esoteric ones do, but certainly worth mentioning here. Particularly Gentoo because of Chrome OS being the main implementation of it, and then Container Linux and Core OS are really in the core the container ecosystem for like if you're familiar with something like Docker, these are kind of purpose-built Linux distros for running Docker containers and Kubernetes clusters and things like that. And then, of course, Android, as we all know, runs on smartphones. Its package manager is the Google Play, and then it uses the APK format. And then some of its popular distros would be Cyanogen Mod, and then in Lineage OS in recent years, Oxygen OS, which is, I think that is Huawei's operating system customization of Android, and then Android One, which is kind of a low-end version of Android for entry-level devices on in some emerging markets for that. So all that to say is these Linux distros, what you can do with a Linux distro is you don't have to worry, you don't have to feel intimidated by the sheer number of Linux distros out there. So in the event that I want to learn like a particular ecosystem, like say I wanted to focus in on learning Debian, for instance, if I learn Debian to some degree, then I have a lot of transferable knowledge to Ubuntu. Or if I learn Ubuntu, I'm going to have a lot of transferable knowledge into the Debian space, because they do have a shared heritage, and they do cross-pollinate quite a bit between versions, the Debian Ubuntu ecosystems and the Knoppix and Debian ecosystems. If you learn one, then you're going to have a lot of transferable knowledge to other Linux distros. So it's not like if you learn Ubuntu, you're going to be completely green if you go to a Debian or Knoppix. And even so, if you learn the Red Hat ecosystem and you learn how that works, you're not going to feel like you're completely out of your element if you went to Ubuntu and started to do things there, because even though you might learn how to install and manage a CentOS, for instance, you can go into the Ubuntu ecosystem because you're going to learn things like how to use the bash command line. You're going to learn how to configure and manage Nginx, and the paradigms for Nginx and CentOS don't really change that much between CentOS and Ubuntu. You just have to figure out how to make it work on this new operating system that you might not be 100% familiar with. But the point is just because you learn one, the more you learn about one given Linux distro, you're going to have that much more transferable knowledge into other Linux distros as you move along. So that's kind of the story there with Linux distros. I do want to mention the Linux desktop, because as I mentioned, this is kind of how this, if you've never started in Linux, this is going to be a way to ease into Linux without having to really commit to memorizing a bunch of command line commands. And so what a Linux desktop stack looks like, it's going to insulate you from the Linux kernel itself and get you away from the command line, because it's going to have the Linux kernel, and then it's going to put on top of that what we call a window manager. It's called X Windows or simply X, and then it's going to put a window manager on top of that, and then you're going to have a lot of different GUI applications running on within the context of that window manager. So this Linux desktop experience really insulates you from some of the nitty-gritty stuff of what you have to do if you just want to interact directly with the Linux kernel or make low-level API calls, or say you're programming in C. You don't really have to know anything about what's underneath that application or that window manager to even get started with Linux. You can really focus in on just running those top two tier things, the window manager and the application, and never even touch anything much below that if you want to ease into the into the Linux experience. And that's because the Linux desktop is a viable option for doing just that. So there's a lot of different desktops to choose from in the Linux space. You have these are probably the six most common ones, and I'm going to show you a table here in just a second, but these are just screenshots from them. So you'll see here within the context of these Linux desktops, you have a lot of different different approaches to the way it may look, but you'll also see some commonalities between it and paradigms that you might have gotten used to in using Windows or Mac OS. You can see it. You have things like something that looks akin to a start menu. You have Windows controls overlapping windows. You see applications, icons, and different things that are very familiar to you if you've ever used an operating system on a desktop. So these aren't departing radically from paradigms that we already know and already use in our common day-to-day experience with Windows machines and Mac machines. So depending on how much you like the Mac OS or how much you like the Windows OS depends on which one of these you will choose, and depending on how much eye candy you like depends on which one of these you will choose as well. So to kind of make the point there is to kind of look at some of the baseline requirements for some of these various desktop environments. So I selected the Ubuntu editions of these simply because you can download a full-blown distro for any one of these desktop experiences but have Ubuntu as the underlying ecosystem for it. So there are 6 different desktops that I mentioned, and that's not even all of them. These are kind of the popular ones. And in each one of them, it has at least one distro that you can download and use, and it will have a full-blown installed Linux experience right off the install. And these each have different system requirements, and that's because they're catering to a different crowd depending on what you want. So KDE is obviously the heavyweight here, and it minimally needs 25 gigs of RAM installed and at least 2 gigs of RAM to run. The same for GNOME and Cinnamon. GNOME and KDE and Cinnamon, though, I would highly, if you're going to run those, they have a minimum of 2 gigs of RAM to run. The reason I put a star next to that's a minimum. You really want to have at least I would say at least 8 gigs to run KDE because it is pretty heavy. GNOME and Cinnamon maybe 4 gigs. And I put a star next to that because generally to run these desktop experiences, you really need to have a graphics accelerator. So you would need something like a graphics card in your PC that is going to give you something like a NVIDIA graphics card in there or an AMD graphics card. And maybe in some CPUs like from Intel have integrated GPUs in them, but you want to make sure that you have accelerated graphics to make these things run because these different desktop environments are going to require that. Otherwise, it's going to tax your system and it's going to be unusable. The bottom 3, as you can see here, are more minimalist approaches to doing Linux on a desktop. Mate, XFCE, and LXDE have much lower system requirements and don't require the accelerated graphics. In fact, Mate is the one I prefer simply because it is a more minimalist approach to Linux. And but at the same time, it's feature rich in that it's got enough operating system to make it very usable and likable. It just doesn't have the glitz and eye candy of Cinnamon, GNOME, and KDE. And so it's actually the one that I prefer to use for more low-end systems like a Raspberry Pi, for instance, is one way to get Ubuntu made up and running. XFCE and LXDE are really nice if you just want a bare bones in a version of Linux that you don't have very much hardware to install it on. Or if you just want the absolute minimum desktop, those are certainly ones that you can approach and get those up and running with very little fuss. But again, it is very bare bones, so don't expect much out of them either. So that's kind of the story for those. And you can download those from any of those sites there. So to install Linux, how would you go about doing that? If you've never installed Linux, basically the way to do that is just to go out to the site and download the ISO. Or you can use a utility, which I'm going to show you this utility in a minute, and it actually does a lot of this work for you. When you get the ISO, if you're going to if you need to make bootable media, you make bootable media. If you're doing a bare metal install, that is, you're installing this on a PC, like a desktop PC or a laptop. You make bootable media like a USB drive or a CD. You burn as CD. After you get the bootable media created, you boot from the ISO or you boot from the media, and then you install the operating system. So it's pretty much a 1, 2, 3, 4 step. This little utility here that I have screenshotted, Unet Boot IN, is a really nice utility because it will take care of those first two for you in a Windows utility. So you can download this and then install it on your Windows or Mac PC, and then you can select one. You can select a distro here, and it will actually download that for you. And then you can say type right here, and you can burn that to a DVD, or you can make a USB drive out of it, and then it will actually create that media for you using this utility. Or if you want to burn, if it's not available from the drop down here, you can bring your own disk image, you can bring your own ISO, and then use that. So with that in mind, let's go ahead and let's go look at I have no idea, unit boot in, and what it might look like to install Linux on a VM. So with that in mind, let's go to the desktop here, and I already have this pulled up right here. So this is the uboot, and this is the little utility here. I can pick from any number of different distros. Notice we have CentOS there. There's a lot of here. Some of these I've never even heard of. Ubuntu, if you wanted to use Ubuntu there. Linux Mint is one for Cinnamon desktop. You can come down here, get Ubuntu desktop, or you can get any number of like Lubuntu or OpenSUSE. I would go with if you're new to Linux and you just want a recommendation, go with Ubuntu. Go with an Ubuntu flavor. Xubuntu would be XSFCE in Ubuntu, and that's a very minimalist approach. Or if you just want an easy to use one, go with Lubuntu. Not Lubuntu, Linux Mint, and that's a real easy one to use. I'm going to show you that one in a moment because it's just so easy to use. It's very familiar if you've used Windows before. And then you select, I want to burn to a hard disk or USB drive, and then you can make that media there. So what this is going to look like if you want to create a virtual machine, once you have the ISO downloaded and you're installing it in a VM, you can actually skip past the media creation. You can actually just download it straight from the website and boot off the ISO right within the context of a virtual like VirtualBox or VMware, or even using something like Hyper-V or Parallels on Mac OS or VMware Fusion there. Now, creating a Linux VM is very simple. It's not hard to do. In fact, this is one of the easiest ways to get it up and running, and that's to pick your version, your type of install. I'm going to use Linux, and then so if I wanted to use Ubuntu, I can choose the amount of RAM depending on the one I'm using, and then select the give it a name and so on. I already have one named Ubuntu. Let's create this. I'm going to create a new disk. 20 gigs should be fine. And then once you have this, I can come over here and then come into my settings. I can come down to my storage, and then you got to figure out how to mount the ISO into your various virtual machine. And once you have this up and running, once you have the virtual CD drive pointed to your ISO and you have your virtual machine configured, you might want to add in some more cores to it, and then turn on some acceleration, and then turn on some acceleration for it. And then once you start this, it'll actually start the boot media, and it'll start that boot media up, and then you can install the operating system. Now, of course, this is going to look different on every distro of Linux. The operating system is going to have a different installer. Some of them are more text-based, some of them are graphically oriented, and just depends on the operating system and the distro that you're using. I'd say most of the Ubuntu ones are going to be graphically oriented, with few exceptions, but most of them are graphically oriented. And you just can boot from the CD and walk through a graphical installer, and it'll format your hard drive on your virtual machine or on your boot or on your physical machine. And then once you have that up and running, it will walk you through that installer, which is usually just a wizard of some kind. And once you get that installed, it's going to look, I'm going to pull up because this does take a minute to do. That's still churning. It's going to look something like this. This is a Linux Mint already installed, and it's going to have a desktop, a familiar desktop experience with Linux installed on that desktop experience. So using those utilities plus or just creating a virtual machine is a very easy way to get into the Linux experience, to get something that you can use right off the bat without having a lot of hassle and just have an experience that is very easy to use and get you into the ecosystem without having to sit there and fight the CLI or have to Google everything just to figure it out. Because once you get this far, you're going to be very familiar with things like dealing with desktops and so on, music, picture. These are all very familiar concepts if you've been using a PC of any kind for the last 10, 15 years and so on. So here's that other one that's been booted up. It's booted into this ISO. And what it's going to do is this is what the wizard is going to look like. And this is the installer. So this is a graphically oriented one. This is Ubuntu Mate. I installed Linux Mint on this other virtual machine behind me in this window. This is Ubuntu Mate, and you could walk through this installer and install this on VirtualBox without a problem here. So a very familiar concept, installing an operating system. So that's the graphical installer, but some of them are text-based. So let's go back to the deck and look at a few other things here. So let me get out of the VirtualBox here and close that virtual machine and go back to my deck and talk about different ways to experience Linux. If you're like, we've already mentioned one, and I just showed you that as a virtual machine on your computer. This one's actually very easy to do. Download VirtualBox, download VMware Player, install that on your machine, and download an ISO and install Linux. That is precisely the procedure we just walked through in VirtualBox. A second one would be to get a Raspberry Pi. Raspberry Pis are a full-blown Linux ecosystem here, kind of created around a $25 dev board. They come with a pre-built pre-built micro SD card that you pop into the Raspberry Pi, and it's got a Debian-based Linux on it, and you can get other ones. You can get a Ubuntu-based. I like to use Ubuntu Mate on Raspberry Pi, and that's one of my preferred ways to use a Raspberry Pi is using Mate, and once you have that installed on the Raspberry Pi, you have a full-blown Linux computer for $25. So that's a very easy way to get into the Linux experience as well. Another way to do this, and this is something I want to mention here, that is the Windows subsystem for Linux. The Windows subsystem for Linux is something that you can install on your Windows 10 PC, and it will give you kind of a sheltered Windows experience, a stripped-down Linux experience that's not a full-blown Linux experience, but it allows you to run a lot of Linux applications within the context of Linux. Now, the only caveat to this is, as of right, the current production version, this 1.0 of the Windows subsystem for Linux, some applications will work on it, some don't. So it's kind of a mixed bag as to what will and won't work on Windows subsystem for Linux currently. Now, version 2 of this, which is in the Windows Insider for Windows 10, is going to have a full Linux kernel running as a lightweight VM behind the scenes, and it's going to have a much more robust experience for Linux on Windows. So I'm looking forward to see where that goes for 2.0. Currently, I don't really use WSL on Linux simply because it doesn't do everything I want it to. It's because it's too limited for what I do in Linux. Now, for some people, it might be just enough, and that's fine, and that's okay. If it does for what you want it to, it's just an easy way to get into Linux on the Windows platform. And version 2 of that with the full Linux kernel on there, if it supports everything that Linux does within a subsystem on Windows using a stripped down Linux kernel, then maybe it'll change my mind and I'll start using that instead of using virtual machines to do a lot of my work on the Linux platform. A fourth one is a VM in the cloud. Now, the reason I put this in terms of precedence, 1, 2, 3, 4, this one is probably the fourth hardest one to use, simply because most VMs in the cloud, if you go out there into Azure or AWS, you spin one of these up, they're most likely going to be just the CLI only. So you have to know something about the Linux CLI to use that. Now, so there might be some third-party offerings on the cloud that have a desktop experience, but getting into that desktop experience is going to require some knowledge of networking and have some kind of client on your PC to connect to that. So it can be done. I actually use VMs in the cloud all the time running Linux, and some of them actually run GUIs from time to time as I need them. But even so, Linux VMs in the cloud can be a challenge if you're just going with some of the CLI only approaches for those VMs in the cloud. And then lastly, I put this one as the last one in terms of ease of use, and that's an old computer. Sometimes an old computer can be a completely seamless experience. Sometimes it can be a royal mess, because the difficulty with a laptop, say you have an old laptop sitting on your desk and you think, hey, maybe it'd be a good idea to put Linux on there. It might go on there without any issues and it might work perfectly. And it might be like some of my past experiences on Linux, it just does not work at all. Sometimes it won't even boot. And I have successfully got it to some operating systems that wouldn't even boot with some finagling and with much grievance, but it was not a seamless experience. It required me to have deep knowledge of drivers, compiling drivers for certain devices on the platform, compiling the kernel, doing all these other crazy things just to make it work right on one given PC, which can be a pain in the neck sometimes. So if you want to try it, I certainly don't discourage you from trying it. But at the end of the day, if you've never used Linux and you try to make it work on a PC, it could be a good learning experience if you're up for the challenge. But at the same time, it can also be very frustrating too, because it's not always guaranteed to work. Because as good as Linux is, it's not perfect, and a lot of the issues that it has particularly with PCs that were designed to run Windows is driver support just isn't there. And because of that, it makes it hard to make it work on everything. However, in recent years, it has gotten a lot better. So so if I had to pick one for running at home, virtual machines and Raspberry Pis, and then these other three would be kind of some secondary ways I might challenge. You might want to use it. So with that in mind, let's go ahead and look at some of the more technical details of Linux, and then save some room for questions at the end. I do want to look at the Linux file system simply because this is something that was inherited from Unix. It basically, it's a little different from Windows. If you've ever experienced the file system on Windows, it's not case sensitive. However, in Linux it is. So capital F file.txt is not the same as lowercase file.txt. You can actually have both those files exist in the same directory, because Linux sees those as two different file names, while Windows would see that as the same file name. So that's something that a lot of Windows users get wrapped around the axle with whenever they get into the Linux ecosystem, as they say, it's the same file. No, it's not. In Linux, the case matters. All files have an owner and an owner group. And then this is something I want to unpack on the next few slides. But every file has an owner, every group, every file has its own group, and every user in Linux is his own group. And so every time you create a user, he automatically gets a group that is the only member of that group is himself. And you can have other groups like you can in Windows, and you can assign multiple users to those groups as well. But if you create a file with your user, automatically the owner of that file is going to be you, and the owner group is going to be your group that is associated with your user. So your sole user group, I guess, for lack of better words. So you would be both the group and the user on that file. And then every file has the world permissions as well, which we're going to talk about here in a second. So as I mentioned, every file in Linux has a user, has a group, and it has a world permission. And these are typically represented by three bits. RWX. R is for read, W is for write, X is for execute. Unlike Windows is the executable is determined by the file header. So a Windows executable file has a certain header in it that makes it executable, and then you typically have a .exe extension associated with that, or a .js if it's an executable JavaScript. The user requires some kind of interpreter. In Linux, to make something executable, you have to have a bit switched, because Linux will see a script as an executable, and if you don't have that bit ticked, you don't get to execute that script. So every user, every group, and the world all have these three permissions that are associated with every file and every folder on your Linux file system. And each one of these bits is represented by 1 or 0, and then you flip that bit depending on what you want. And then you do some binary math, and you come up with a integer that represents the permissions associated with the user, the group, and the world. So typically, our user permissions in the Linux ecosystem are expressed as some 3-digit number, 7, where each digit is between 0 and 7. So 764 means that the user has read, write, execute, the group has read, write, and the world only has read permissions on that that particular file, whatever 764. Or if you saw 744, it would be the user has read, write, and execute, but the group and world only have read and write. So you can see how each one, you can control the file permissions for a given folder or file on Linux using these various integers to represent those different bits, whether it be read, write, or execute. So with that in mind, I do want to talk about one special user, and that's the root user. Now, every Unix and every Linux machine comes with a root user, and it's analog to the administrator account on Windows. And root is it basically has access to everything on the system. So everything, it's the first thing that boots, and it can see every file, can read every file, can write every file, can execute every file. And because it's such a powerful user, it's something that you don't really want to use on a day-to-day basis. In fact, you should probably never even log in as root, or even enable it as a login account. Now, on Linux, you can some accounts are what we may call a service account, similar to a Windows service account, and it's used basically to run a service of some kind, and it's not something you allow a login for. And root's one of those accounts that you don't want to ever enable as a login user on Linux, and simply for permission or security reasons and security reasons alone, because it has so much power on a Linux system. You generally shouldn't ever log in as it or make it even a login account. And that's where the idea of sudo comes in. And sudo is a way of doing root level things on Linux without actually having to log in as the root user. And you can assign people to the sudo account without actually having and then you can use sudo to prepend commands, and then sudo will protect those resources, and you have to execute everything through the sudo command in order to make things happen at the root level. So if I set up my virtual machine in VirtualBox, then I'm automatically assigned to the sudo group on that particular box, and then I can execute commands as sudo that would otherwise require root level permissions on them. So let's go ahead and do a demo. Let's talk about files, and then I'm going to do a CLI demo and then save some time for questions at the end. So let me pull up my Linux Mint VM here. Let me go back to the deck here, and I do want to talk about this. And that's the CLI. I'm going to do a demo, combine those last two demos because we're running a little short on time here. I do want to save some time for questions. And the Linux CLI is often referred to as a shell. And the shell is the environment that the CLI is running in. And the shell uses one or more shell environments, but the most common one by far is called Bash. Bash stands for Born Again Shell, and there's actually ones called Corn Shell and T Shell, and several other ones that are just shell. Bash is probably the most common one. So if you're ever going to get into CentOS or anything in the Debian space, Bash is going to be the default shell for even the Windows systems. For Linux is going to default to Bash as well. So it's one that most people are going to be familiar with. So they're almost used synonymously between shell environments and Bash. And then lastly, a shell is actually accessed through a terminal. In fact, macOS calls the app is called Terminal in macOS. And so a couple of things that you might want to, and there's several things that you can do within the terminal that are very familiar, and that's these common commands here, like navigating directories, working with files, working with users, working with processes, working with permissions, and so on. So I do want to do a demo real quick though to show you some of these different commands. Like I'm going to work with a couple of these commands here, and do some stuff with some of these commands right here, and maybe even do some stuff with permissions as well. And I'm gonna do it in the user interface, the GUI, and then I'm gonna turn around and do it again in the CLI. So combine those last two demos to show you kind of what this would look like on Linux. And let me go back over here to my Ubuntu demo machine here. So let's say I am in my documents folder here, and I'm going to create a file. Now I'm in the Windows here, and I can go to create new document here, and I'm going to create an empty document. So I'm going to call this one, I'm going to call it file.html, sh, and that's just a shell script. So I'm going to open this up with text editor, which is just a text editor in, like Notepad in Linux. And I'm going to go, I'm going to make a little shell script here. I'm going to say use the interpreter bin/bash, and then I'm going to go echo, hello world. So this is hello world on a Linux shell script. And I'm going to save this guy back to this file, okay? So once I have that saved, I can minimize this, and then I can come over here and right-click on this, and this is something that you might be very familiar with inside of Linux. And so here on this properties things, you can see I have the permissions tab right here. And I'm the owner of this, and my user and group, my one-member group called Blaze, as I'm the owner and my user is the group for this particular file, and it has read-write permissions on it. So if I wanted to assign read-only permissions to the group or no, I can do that. And notice that the world access is read-only. It doesn't call it read-only, but that's the general read-only access. And I can also tick this back here to allow executing this as a program. I don't like the way that this particular user interface does this, because this is basically assigning executable permissions for everyone. I think that's what it's doing for both the user, the group, and the world for this particular file. I would like the ability to do this individually for the user group and file, but this user interface doesn't allow me to do that. So that's something I can actually do in the command line if I wanted to. But in any case, I can unclick that to make it executable and so on. So within the context of this particular GUI, that's how I was able to create this. Now, I'm going to go back over to the CLI now and do basically the same task. Let me go ahead and delete this file here, and I can actually do that from the CLI. And I'm going to show you to show you that the CLI doesn't have to be intimidating if you've never used the CLI before inside the context of Linux. So let me go ahead and boot up the CLI here. This is a terminal running bash. And to run some of those commands that I just did, let's see. If I type in ls, that's going to give me a list of directories. So that's kind of like dir. You can use dir and analog to it. And so I go change directories to documents. I can do doc tab, and that's a shortcut key that will pre-populate it based on what I have here. So let's say I want to edit a file inside of the CLI. Well, generally speaking, Ubuntu is going to have a text editor called Nano, which is very easy to use. So I'm going to call it, I don't know, let's call it file.sh. And edit this file. So I'm in a text-based editor, and I can create that file in this text-based editor just like I did in the GUI-based one. So the interpreter for this is going to be /bin/bash, and I'm going to do echo hello world, if I can spell right. I think I got that. I think it's, and then Control O to save that, and Control X. Now, if I do ls-l, I can see the permissions on this right here. This is the RWX thing, or sometimes it might be expressed as numbers. And so that's telling me that I have read-write permissions, and the group has read permissions, and the world has read permissions. So let's say I want to add executable. I want to make this executable. So I can do a command called chmod, and I'm going to go +x, and that's going to assign executable permissions to this file. And that will then make this same file executable now for everyone. So it's essentially doing it for the world and the group and the file. So to execute this, I would just type in that right there. Now there's a bug in this. Let me go back and edit it, because I got this. This should be like that instead. That's why it gave me that error. And if I execute the file again, it just says hello world. And so I basically just wrote a bash script and then changed the execution permissions on that, and then executed it as well. So say I wanted to install some software on my machine here. Now this is something that I can do in the CLI, or I can do in the GUI as well. I can go sudo apt-get install some package. Let's say I want to install Nginx on my machine. So this is using the package manager. That's going to prompt me for my password here, and then I can install Nginx on my machine. Now, if I got the password correct. and it's going to read the package. It's going to ask me if I want to install this. So that's using my package manager here. Now I can do the exact same thing inside of my my Linux Mint distro here. As I'm a little slow here because I'm taxing my machine here. Okay, now that's better. I can hear the fan spinning up in the background on my machine here. So if I wanted to install this Nginx here, I could go to Synaptic Package Manager and do the exact same thing here. Search for Nginx, and it's going to search the packages here, and I can scroll down and find Nginx here. And there's the same package that I would have otherwise installed with apt-get, and I can mark it for installation. And then it's going to tell me everything else is going to install, and that's because it's doing the exact same thing apt-get would install at the CLI. And then I can hit apply up here, and that would install Nginx exactly the same way I did if I ran it in the CLI. So you can see here that I can do a lot of the same kinds of things in the GUI as I can at the CLI within a GUI-based Linux operating system. That's kind of the whole point of this demo here, is to show you that you can do a lot of the same kinds of things within a GUI that you can do in the CLI. And so this is a good way to kind of get you into the Linux experience, so that you understand conceptually what's going on with Linux using a GUI. And then as you learn the system, you can learn the associated commands that go with it by learning the analog commands inside of the CLI. So apt.get, for instance, is you can use Synaptic Package Manager. Like I created a file, changed the permissions, and edited that file in the GUI. I can do that at the CLI just as easily. So all that to say is there's two ways to do it in this, just like you could do in a Windows machine. But ultimately, where Linux is going to lead you is into the CLI environment so that you can go forward from there. So with that in mind, let's go back to the deck and just did a demo there. I do want to save some time for questions, so I'm going to pop open the questions menu here. So first question is, Red Hat is moving away from X11 to Wayland. Is this true or for also distros as well? Yes. Other ones are moving to Wayland. Wayland, as I mentioned back in the stack, away from what we were talking about a minute ago when we were talking about desktops. Wayland is a desktop server. It's called essentially a desktop server that allows you to do window compositors. That's a technical implementation. It's really not going to matter for the average user as to which one of these you're actually running under the hood. X11 has just been around for 30 years. Is it true for other distros? It is. Some have tried it. Ubuntu's tried to go that way, but Wayland has just not gotten traction. So they're just still using X because X works. With all its warts, X just works. Wayland hasn't got. It's still buggy and its stability issues. I think is why people haven't adopted it wholesale. So next question here is, if I write an app, do I have to compile it for each Linux OS? That's a good question. Now, depending on what platform you use, depending on the platform, that can't. Sometimes you do. If you write it in C or C++, you might have to compile it for every Linux distro. If you write it in .NET, you don't. .NET, you write it in .NET Core. That'll run on CentOS, Ubuntu, any of them, and all of those are just to. You don't have to compile it. So it just really depends on the platform. If you wrote it in Java, no, you don't have to compile it across every Linux OS. Typically on the more low level the languages, the more often you're going to have to compile it though. So like I said, with C++ and so on, that's going to be the case there. If you have to compile it for each app. What is sudo? Sudo is it's a utility on Linux that allows you to run essentially root level commands without actually having to be logged in as root. So it uses a security wrapper around the command you're running that doesn't give you full root access to the machine, but still will execute the command that you want to run. So if I want to install software on my machine at the CLI, I need to use sudo apt-get install in order to get that root level access to install the software, because I can't just do apt-get install with my standard user. Sudo will allow me to get that root level access without actually forcing me to log in as root. So someone did post an answer down there. I believe sudo stands for super user do. Yeah, I think so. That's what it means as well. But essentially, it's just to keep you from logging in as root, and that's just for security purposes as well. So Fedora is use DNF if you want to update your presentation next time. Maybe Fedora's. I use Ubuntu just because Ubuntu is probably one of the most widely used ecosystems out there. Not because I particularly am partial towards it. It's just it's a lot easier. I think it's a lot easier to get into the Ubuntu ecosystem. However, Fedora is a great distro as well. I think it's a great ecosystem, and the Red Hat distros are equally useful in a lot of different contexts. There's nothing, not because I'm partial to it. It's just Ubuntu's just got the entry level for Ubuntu. I think is a little easier, and it's just well documented, and it's a lot of user support, and a lot of applications run right out of the box on top of Ubuntu for that reason. Next question is, what is the most popular toolkit for creating applications, i.e. Motif, Qt, GTK, etc.? Probably Qt or GTK. I would say Qt probably. I don't know that I have any current stats on it. I've seen a lot of work done in Qt and actually done a little myself and done some in GTK. We're creating app for, but most of the, I will say though that the recent years, a lot of people are getting away from using specific UI frameworks and going to like HTML5 wrappers. So projects like Node.js within the context of a browser that's actually a sandbox browser that's really a web app running inside of a installed browser that's really just running your app. Electron would be an example of that, is to make things cross-platform. Is a lot of applications are going that way. What would it be a good idea to install as a primary for .NET Core development? No, you don't need to do that. Just compile it cross-platform, and you can use Windows for .NET Core development. The only thing I would do is, if you intend to use it, is just test it on that, but you don't have to install it for .NET Core development. For someone that is new to Linux, what distribution of Linux would you recommend? I would start with Linux Mint, one I did. That's very easy to use especially for Windows users. Linux Mint is just very easy to get into for newbies. In fact, I started off way back in the dinosaur days of Linux, where it was basically you didn't have much of a choice. You had Red Hat, and that was kind of the only game in town, or some of Windows derivatives. But definitely, I think Ubuntu ecosystem with Linux Mint is one of the easiest ways to get into, the one I demoed just a minute ago. What's your opinion of Linux from scratch, distros like Gentoo? My opinion, if you like to do that kind of stuff, if you're just interested in learning about it, getting hardcore into it, sure. And then not a bad thing. I don't, if you want to go down that route, and build your own Linux ecosystem, that's fine. Your Linux from scratch with something like Gentoo. Folks have done that. I don't typically have the time to deal with it, so I typically just go for a prepackaged one, and just go from there. The only time I really use a bare bones Linux distro or Linux that's kind of more that is if I'm doing it for purpose-built systems, like using Alpine Linux for running something like a Docker cluster or something like that I don't need all the other stuff that comes along with a general purpose distro like Red Hat or in its progeny, or DB and its progeny. I meant to in the grid just showed you. I just meant in the grid. Okay, sorry. I got you. Is PuTTY is PuTTY still being used? That's a question that came up. Yes, PuTTY is being used. Actually, I use PuTTY all the time. You can use SSH too in Windows now that it's been cross-compiled for it. I'm just an old dog that's hard to teach new tricks to, so I still use PuTTY for all my SSH stuff from Windows into Unix systems. I've learned to use that and learned to appreciate it, and that's the one I use. It's not the only game in town though, and it's actually still being actively supported and used. So, last question. 2 more questions, and I think that'll be the one of the last ones here. Let's see. How do I make sure I get the latest? How do I make sure I always stay up to date with security? Now, it depends on the distro. Now, if you do an apt-get install, and it's going to install the latest stable version of the software, and then with certain distros, you can opt in to do automatic security patches. Most of them will support something like that, so it'll automatically install security patches on your machine, and then require a manual update for latest packages. But that's going to be generally handled through your package manager. And then some will have a third party services that you can add on to Linux that will manage updates for you as well, especially if you have a server farm and you're running literally hundreds of Linux servers and you want to maintain packages. You can use third-party software to do that as well. But if you're just running it on your local desktop, opt into the security patches for automatic is what I'd recommend doing, and then occasionally run apt-get-update for Ubuntu or yum -update for Red Hat, and that will update your commands, update your packages that you have running on your system as well. So that's basically baked into your operating system distro there. In your experience, what has been the best resource for learning the Linux command line? Is it a good cheat sheet, especially one that translates Linux users into DOS? Is there a cheat sheet out there? I don't know of one, but mine is the way I learned it was come up with an idea. I'm gonna run WordPress on Linux. So you go through the process of setting up a Linux server and then installing the software you need and then configuring that software to run WordPress, then installing WordPress on that system. So those kinds of projects, if you will get you into learning Linux. So I always have to have a problem I'm trying to solve with the tools I have available. That's how I learned it. Now, not everybody learns the same way. So the best way I learn is just by doing things. Some people learn well by just by going out there and just randomly typing in commands and kind of figuring out what they do and how they work. And so for me, it's largely been just the experience of getting into the operating system and solving a problem and then trying to figure out how to make things work. And at the end of the day, that's been how I learned Linux from, I started using Linux probably in the late 90s and have been using it for about 29 years now, I guess, not 29, 25 years now. I've just mostly just been through trial and error in a lot of ways. And I'm glad to see that it's finally emerging as a mainstream concept within the dev community. And so the idea that just to learn it, solve a problem, figure out how to install stuff on it, just learn it by doing that. I hope I've given you some tools to kind of help you ease into that process by using the GUI along with the CLI and just figuring out how to do things in the GUI and then understand the concepts of how it works and then translating that into the CLI and so on. So if there's no more... some more questions down here. What's the difference between Unix and Linux? That's a deep question, but the difference between Linux and Unix really has more to do with the ecosystem. Unix is actually an old operating system that was invented by AT&T. Linux attempts to maintain backwards compatibility with that, but in any case, there is Linux has kind of emerged as its own ecosystem apart from Unix, but still maintains a great deal of backwards compatibility with that with Unix. So it's kind of the difference is that Linux is just one of the latest start.nix derivatives. So BSD, Mac OS, all of those are essentially Unix compatible. They call them POSIX compliant operating systems that try to maintain a backwards compatibility with Unix, but have their own ecosystem as well. Is there a help command in Linux? Yes, there is. Google is great for figuring things out. In fact, I find myself Googling things more often than I do using the built-in help. But any command in Linux, typically if you type man into the CLI space command, like man space CD, it'll give you the man page as it's called. Essentially, it's a built-in help doc within the Linux CLI that will tell you what the command does and all the switches for that command for that. So... but yeah, Google stuff. Google is great. I use Google probably more than I use man pages just because Google, you can typically get better answers anyway. Clear Linux from Intel is seeing a better performance in benchmarks than Ubuntu and Fedora. Do you use their document? Is there a good documentation for this distro? I honestly don't know. I've never used Clear Linux. again, I take benchmarks with a grain of salt too, because the benchmarks are, what are they doing? What are they benchmarking? Because not if you just run like pure benchmarks on like CPU raw performance within a Linux distro, that's great. But at the end of the day, that's not the only thing that I care about. I care about things like ease of use or maintainability, and other things like that. So if Ubuntu is not as high performant as maybe a more less supported OS, I'm typically going to go for a more well supported OS to put my applications are in a production environment than I am going to go for one that just might get a few more, that might be 10% faster or something like that. But in any case, so I didn't hear your thing about .NET HTML5 applications in .NET. HTML5 applications in the context of Linux, using something like Electron, which is a cross-platform environment that allows you to essentially write HTML5 applications that are GUI applications that are underscored by something like Node.js that run, that allow you to have your GUI written in HTML5, but you have the power of Node.js behind it. That'll run on Linux. It also run on Windows and Mac OS as well. And the same thing with .NET Core. You can write .NET Core applications on Windows, cross-compile them, and run on Linux, Mac, and Windows as well. Windows version of SSH works nightly. Sure, it does. I'm an old dog, and it's hard to teach me new tricks. I still use PuTTY. Since it's open source, you're wanting to less stuck waiting for someone to fix security issues. I'm not sure what that's in reference to. And then something related to system in commands and so on. So all that to say is, okay, security issues. Yeah, okay. Related to the question about security. No, typically I will say that Ubuntu and Red Hat Linux distros and their progeny are really good about doing what they call zero-day patches. And what they will do, and then we'll also do, is they'll backport patches into old versions of software as well. And the difference between CentOS and Linux and the Debian ecosystems typically has to do with how aggressive they are on adopting newer packages, newer versions. Debian is typically more aggressive about running the latest versions of things, while Red Hat-based distros are typically more conservative, running older versions of it, but they don't ever skimp on security patches. So if there's a security patch, they'll backport it into old versions of the software as well as put it into the latest versions as well. So the security patches, I would always opt in for automatically installing those on systems, especially zero-day patches, because sometimes those you don't even know about them. Like Heartbleed, for instance, a few years ago really affected the Linux ecosystem because OpenSSL practically is baked into everything on Linux now. And because of that, it needed a zero-day patch to fix the problems there. And then you had to go back, basically redo all your reissue all your certs in case they got leaked. But in any case, are there people dedicated to fixing issues on all the community, or is it all? No, there's actually dedicated people for fixing issues on within. So Oracle and Red Hat and Microsoft all have people working at those companies that are actively contributing to those projects, and they're actively patching them. So they have a vested interest in making sure the software is secure, because they get kickback from that by providing professional services for running Red Hat Linux or running Ubuntu on Azure and things like that. So they have a vested interest in making sure that it's not just community-based, it's actually a group effort between the community and corporations like Google, Red Hat, Microsoft, Canonical, all the other big players in the Linux space. All contribute to the patches for those. So you're not relying strictly on the community for that. Even some of the more esoteric distros will ride the wave of the more popular distros because they are within the context of that ecosystem. So even if I'm running like a more esoteric version of Ubuntu, for instance, that maybe isn't mainly maintained by Ubuntu, it's going to ride the wave of support that is given by the Ubuntu ecosystem, because Ubuntu is going to be pushing patches, and because it's downstream of that, it's going to pick those patches up and apply it to that particular distro. So just something to think about. Even if you're not running a mainline distro, you can certainly take advantage of those patches if you're running it within the context of, like, say, Debian, the Debian family, or the Red Hat family, or so on. So If there's no more questions, please do check us out online. We'll be posting this video, the recording of this video, online, and we will be posting and that will be essentially the slides. There's really no code demos, but certainly do check us out online at wintellect.com. Follow me on Twitter, and tune in next time as we have more Wintellect webinars. And thank you for tuning in this time. Until next time, I'm signing off.